Hier ist die neue Folge der Ökonomie-Videos.
Welcome to the Explainer. So, blockchains, they're these amazing decentralized networks, right? No single person in charge. But that raises a huge question. How does everyone agree on what's true? Well, today, we're diving into the fascinating systems built to solve that exact problem, the quest for consensus. And the best place to start is, of course, with the OG, the original consensus mechanism, the one that powers Bitcoin. But this pioneering technology, well, it comes with a very well-known and frankly pretty controversial problem. That's right. We're talking about its enormous energy consumption. This single issue has sparked a huge global debate about sustainability, and it's really what's driven this whole search for a better way. A way to create trust without that massive environmental price tag. So let's start with that original design to see how it all works. All right, first up, the incumbent, proof of work, or as you'll often hear it called, POW. The easiest way to wrap your head around it is to just picture this massive, nonstop, global competition. You've got literally millions of specialized computers, these miners, all racing against each other 24/7. They are burning incredible amounts of electricity trying to solve a really complex math puzzle. The winner, the first one to crack it, gets to add the next block of transactions to the blockchain, and they get a reward for their trouble. And right there, in that little description, you can already see the core trade-off of the entire system. On one side, this constant, super energy-intensive race makes the network incredibly secure. I mean, to attack it, you'd need to outcompute everybody else, which would be astronomically expensive. But on the other side, as we've said, it comes at a huge environmental cost. And this fundamental tension, it led developers to ask a really crucial question. Can we get all that security without the gigantic power bill? This question really paved the way for a major challenger to emerge, which brings us right to our next section. So let's check out the alternative model that came out of that question. Meet proof of stake, or POS. You've probably heard of this one. It's the system the Ethereum network famously switched to back in 2022 in that massive event they called the merge. With proof of stake, the game completely changes. It's not a race based on who has the most raw computing power anymore. Instead, it's a lot more like a lottery. Here, participants, who we now call validators, they lock up, or stake, their own crypto as collateral. The more you're willing to stake, the higher your chance of being randomly picked to create the next block. So you might be wondering, how do you actually do this on a network like Ethereum? Well, becoming a validator isn't just about putting up the cash. There's real risk involved. You've got to stake at least 32 Ether, run some specific software, and crucially, stay online. If you fail to do your job right, if you go offline or try to cheat the system, the network can automatically take a chunk of your staked Ether away as a penalty. That is the skin in the game that keeps everyone honest and secures the network. Okay, so we've got these two main ways of getting everyone to agree. One based on pure computational work, and the other on having capital at risk. Let's put them side by side so we can really see the critical differences and those all-important trade-offs. When you boil it all down, the difference is actually pretty simple. Proof of work is about proving your commitment to the network by burning real-world energy through computation. Proof of stake, on the other hand, proves your commitment by locking up your own capital. This simple but really profound difference leads to some dramatically different outcomes for the networks that use them. And here's the key point. There's no single perfect solution. Proof of stake has these huge advantages, right? Energy use plummets, and scalability, the ability to handle more transactions, goes way up. But its security model is much newer and a lot of people would argue less battle-tested than proof of work's incredibly robust brute force approach. It really is all about deciding which trade-offs you're willing to live with. Now, while proof of work and proof of stake absolutely dominate the conversation, they are not the only ideas out there. The hunt for the perfect consensus mechanism is far from over, so let's just take a quick look at a couple of other interesting approaches. First up, you've got something called proof of importance. This is used by the NEM network, and it's kind of like a souped-up version of proof of stake. See, it doesn't just look at how many coins you've staked. It also rewards you for good network participation, things like how long you've held your coins and your recent transaction history. It's trying to measure a user's overall importance to the health of the network. Then there's this one, and it's a mouthful: Practical Byzantine Fault Tolerance, or PBFT. This is actually an older idea from computer science, and it's designed for one thing: maximum reliability. Its main job is to make sure the network can keep running smoothly and reach the right consensus, even if some of its participants are failing or offline or even actively trying to cause problems. So, we've looked at the energy-hungry original, the capital-efficient challenger, and a few other novel ideas. After running through all these different models, what's the big takeaway here? What does this all really mean? The big takeaway is this: every single consensus mechanism is a choice. It's a statement about what that particular network values most. Proof of work? It values that battle-tested, brute-force security above all else. Proof of stake? It's prioritizing energy efficiency and the ability to scale up. And these other systems are exploring totally different values, like rewarding good behavior or guaranteeing extreme reliability. And this leaves all of us with the huge, unresolved question for the future of this technology. What matters most? Is the top priority energy efficiency? Is it maximum hardcore security? Or is it something else entirely? There's no easy answer here, and the path we all choose will be defined by which values a global community ultimately decides are most important. And that decision is what will shape the future of the decentralized web.